Hi everyone. What I want to give a brief explanation of today is the relation between these two shapes. On the left, we have a unit circle. In other words, it's a circle with a radius of 1. On the right, we have a sine graph. Let's consider a coordinate on the circumference of the circle and call it xy. We can also describe the same point by using what is called polar coordinates. For that, we have our polar axis, and we then look at the angle between the red line and the polar axis and call it theta. The point in polar coordinates is then described by its distance from the origin, or the point 0, 0 in the center, and also the angle that it makes with the polar axis. In other words, we've just shown that one point can be described either by xy coordinates or polar coordinates. In order to give these angles, we start at 0 at the positive x-axis, and then we move around in a counterclockwise manner so that we have the 90 degrees on the top, the 180 on the left, 270 at the bottom, and back 360 where we started with 0 degrees. We know that the height of this point is y, since it has a coordinate xy. Let's consider the red triangle. I just have a bigger version of it on the right. We know that it has a height of y. We call the side with a length of 1 the hypotenuse, and the side with a length of y the opposite side, since it is opposite to the angle theta. The relationship sine is given by the length of the opposite side to the length of the hypotenuse. Sine of theta in this case will therefore be y over 1, or just y. Let's now go back to the unit circle. As I said, we start with 0 degrees at the positive x-axis and then move around in a counterclockwise manner to obtain the other degrees. An alternative would be to start at 0 but then move around in a clockwise manner, but then we take the angles as the negatives. For this example, I will be starting at minus 180 degrees and moving around the circle in a counterclockwise manner and ending back at 180 degrees. I make my first point where theta equals minus 180 degrees and y equals 0. Then the corresponding point is made on the right at theta 180 degrees and y 0. My next point is when y is minus 1 and theta is minus 90, and the corresponding point is indicated once again on the right. I do this until I get back to 180 degrees. As you can see, these are points on the sine graph that we originally had. I now quickly want to show you a short Desmos animation which illustrates this. So, we have a very nice animation that shows what I just explained in the previous slides. Just note that in this case, we are starting at 0 degrees and moving on to 360 degrees. Unlike in the example I just showed you on the slides where we started at minus 180 and ended at 180. I hope you found this video interesting and insightful.